Okay, the last chemical bonding and chemical structure that we are going to see is your metallic bond and metallic structure. So we have looked at bonding between metal and non-metal. This one is your ionic. Okay, non-metal, they either form simple covalent substance or giant covalent substance. Okay, last but not least, we have metals. Again, for example, aluminium metal, right? The aluminium that you see in your Coca-Cola can, right? This aluminium cannot be one atom. There are many aluminium atoms or cations that actually join together, or there's an attraction or bond that actually form the aluminium that we see. Okay, so the bond that actually joins the multiple aluminium atoms or the multiple aluminium cations are what we call the metallic bond. So the step one is to name the structure. So the structure is your giant metallic structure and strong metallic bond. So what exactly is this metallic bond? What is the attraction that's holding the different aluminium atoms or different aluminium cations together? Okay, this metallic bond, it is electrostatic force of attraction. Okay, this is electrostatic force of attraction, means this is a positive and negative attraction. Okay, this ESFOA is between the positively charged metal cations. You should know by now all metals will lose electron to form positive cations. Okay, so ESFOA is between the positively charged metal cations and the negatively charged C of delocalized mobile valence electrons. Okay, so for example, we are talking about aluminium. My aluminium metal will lose 3 electrons to form Al3+. When it forms Al3+, 3 electrons are being given out. Okay, so it will lose these 3 electrons, right? These 3 electrons that are being lost will be what we call delocalized to form a sea of electrons that are delocalized, and these delocalized electrons will actually move around the aluminium cations. So they will just keep moving around and it forms a sea of delocalized mobile valence electrons. So the attractive force, the ESFOA, that's holding all these individual atoms together is pretty strong. So this ESFOA is the attractive force between the C of negatively charged delocalized electron and the positive metal cation. So let's see, the electrons occupy the space between the metals and then they are free to move throughout. So like I was telling you, the 3 electrons that are being delocalized, they are actually moving throughout the whole metal cation or the aluminium cation's structure, and then they are called mobile or delocalized. Okay, so because these are structure of all metals, all your metals will have these subsequent properties.